So I would like to welcome everyone to our new series of webinars on AI and industrial solutions. But so first, maybe a quick reminder, this event is being recorded and will be uploaded on your YouTube channel. So if you don't want your name should not appear anywhere in this recording. I am Christophe Lelanou, a board member of the Franco-British Data Society and the founder of Data Learning. So following the success of our first series, AI and the built environment, we are excited to now explore the applications of AI in the industrial world. If you miss our previous webinar, don't worry, you can find the recording on our YouTube channel. So today we kick off this series with OVH, the leading French cloud computing company. They are well established in the north of France, but as our speakers Anaë Bisquet and Alexis Gendronneau will explain, OVH has actually offices all over France and even in the UK. They are always looking for talented individuals, no matter where they are based. Next week, we will continue with a webinar featuring the Chief Data Officer of Total. He will tell us more about AI as an accelerator of the energy transitions. Registrations are now open, so my colleague Anne will share all the relevant links in the chat. Before I hand over to Anaë, let me briefly introduce the Franco-British Society. So we are a new organization with a mission of promoting education on digital and data-related topics, while also providing a networking platform. Our goal is to become an educational charity soon. We bring together a diverse mix of business practitioners, experts, and non-experts who are interested in data and digital topics. We look at this discussion from a Franco-British and European perspective, covering ethics, regulation, digital transformation, AI, governance, education, security, and more. If you are interested in our events, feel free to follow us on LinkedIn or to subscribe to our newsletter. Some of our events, like today's, are free and open to the public, while others are private and exclusive to members. If you like what we are doing, I encourage you to become a member and even an active member. The more we are, the greater the impact we can achieve. So if you have any questions, please don't hesitate to reach out. Again, Anne will share all the relevant links in the chat. Lastly, on the behalf of the Franco-British Data Society, I would like to thank our partner for this series, North France Invest, Artus Gallier, and the British Chamber of Commerce and Industry of Lille, Nick Haidar. Now, without further ado, I would like to hand it over to Anaë, who will introduce herself and OVH. Anaë, the floor is yours. You are muted.
Sorry, yes, of course. Thank you, Christophe, and thank you for inviting OVH Cloud to participate to this webinar. We are very happy to be here, and we want to share with you some use cases and how companies such as OVH uses data and AI for process optimization and efficiency. Just a quick word on OVH Cloud, who we are. The next slide. So as Christophe said, we are a cloud provider. Actually, we are the first European cloud provider and the only major player at a global scale. We have 43 data centers in 9 countries, including the UK. I will come back on that later. Over 1.6 million customers over the world, and we hire almost 3,000 employees, and we have 450,000 servers in our data center. Our really strong commitment is to offer a cloud that's accessible, open, and transparent. But of course, we want it also to be sustainable. Maybe on the next slide, just to show you our international presence. As I said, we have 43 data centers. You can see they are mostly in Europe, France, of course, which is our home country, Poland, Germany, in the UK also, but we have also a very strong presence in Canada, where we also have a factory, and I will also come on that later. And we are also present in the US and in APAC, India, Singapore, and Australia. So as you see, a global player. We have a presence in the UK. As Christophe said, we have an office, but we also have a data center that's close to London in Erith. It's open since 2017, so we've been here for over 15 years with our offices, but less than 10 years with our data center. We are currently expanding, of course, and we have a little more than 50 people in the data center, almost 60. Our VP for Northern Europe is Ima Dinard. She's based in London, and of course you can get in touch with her if you want to. As I said, we are a cloud provider. We are actually a pure player, which means that we only do cloud. We're not as our main competitors that you all know, AWS, Microsoft, and Google, also providers of other services, but we offer all kinds of clouds: public cloud, web cloud, private cloud, bare metal cloud, and we also have PaaS solutions, and we offer, thanks to our partners, also SaaS solutions. So our objective is really to offer the whole range of services you might need with the best price performance ratio and in a very sovereign and secure environment. And that's one of our main differentiators. So that's my next and last slide. With OVH Cloud being, as I said, the leading global provider of trusted clouds, we are European, so we're not submitted to extraterritorial laws such as FISA, Cloud Act, or other Chinese law that our competitors might have to abide to. We are also sustainable. We have the best price performance ratio on the market. We want our customers to be able to innovate thanks to our solutions, and we work in a very dynamic ecosystem. It's very important to understand that, as you see here, we are sustainable by design because we are an industrial player, which is a very strong differentiator of OVH Cloud. We build our own servers in factories that are located in the north of France and in Canada. So it allows us to really implement our own water cooling, for example, technology, but also to be very resilient because we have how can I say, we manage the whole value chain. It's important to understand that because what Alexis will present you is very focused on our industrial way of working, and it's important to see that we are both data centers, but also we have this industrial side. So that's it for me. Alexis, to you to introduce the use cases.
Yeah, thank you, Helen. So let's dig in it a bit. Why are we using AI at OVH Cloud? As you mentioned, Anae, OVH Cloud is an industrial. That means that we are building all of our systems from the servers, the racks, the base, and the data centers, and also wiring our network. Today, the complexity of the systems that we have deployed and also the services that are running over prevent us from using the standard manual or human the analysis of the systems. So that's where the AI solutions, AI techniques help us making our system more efficient. The machine learning capabilities also delivers a scalable and adaptable system because the activity is moving fast. There is a lot of new use cases, and there is a lot of innovation in technologies that we are deploying in our data centers. So having a system that is able to learn and to adapt to the system, to the new usage, is something mandatory to make it relevant in the long term. And finally, it helps our collaborators to focus on their added value instead of doing the tedious work of data processing, data cleaning, and data analysis that can be made with the cloud computing power. So for the first use case, I wanted to just go back on the value chain of the data in OVH Cloud. everything that we build, and especially the AI models, relies on those 4 steps. When we have something that we guess or that we want to improve, we are always start by questioning these 4 steps. First one, do I see everything? If I don't see everything, my dataset will be biased at the end, and my model won't be as efficient as expected. So we ensure that we are getting all the information that we would need in order to build our models, so that afterwards we can go on the second step, which is explaining what we are seeing. And on that step, we need to step back from what we know or what we guess we know, in order to make sure that we're considering the system on the whole, so that we can afterward predict its behavior based on what we explained, and finally prescribe actions to enhance it. So that's the value that we are driving. For that first use case, it's very linked to the topic that you mentioned, Anae, about optimizing our industry. As you can see on this short video, we have a lot of physical servers, because cloud computing is mainly servers that are displayed in racks and bays. You can see here a couple of them. And all those servers consume a lot of energy, of course. So at OVH Cloud, we are designing servers for like 20 years now. And this topic of the power efficiency is something that we started to work on decades ago. And as I mentioned, the complexity of the system now needs an adapted technical solution. That's where the AI came into place. So for the first step, C, we are getting a bit ahead of time. We wanted to design an energy efficient bay and data center. The typical way of building something, building an IT infrastructure, I guess for a couple of you, you take all the parts of the servers, all their need in energy consumption, you sum everything up, and at the end, you allocate the needed, the potentially needed energy. But when you do that for dozens, hundreds, and now hundreds of thousands of servers, this small amount of over-allocated power results in a really huge loss of potential energy usage. So that's a problem regarding the sustainability or the ecology, but it's also very how do you say that? A very common topic. It consumes a lot of money at the end, because you have to allocate power that you will never use. So the issue there was to identify the best ratio between the risk that you take when you lower the allocated power. That the risk is that at the end you don't have enough power to power up all the infrastructure, so the customers will have potentially issues on their services, and also minimize the allocated energy that costs a lot at the end. So what we did in order to create our first step to see how the systems are behaving, we deployed smart PDUs that are actually like smart plugs that will give you a lot of information about the electricity consumption of all of the servers in a rack. And when you gather everything into bays and then data center, you are more able to explain what is happening really on those services. And what is happening actually is that these small over-allocation at the servers level were actually consuming a lot of energy, or allocated energy, that we would never use at the end. So we figured out that we would be able to lower by a great factor, actually dozens of % of the total allocation, that we will remove it from the allocated designs. So first, we tried to validate that hypothesis by deploying a service. After we built the model of prediction, we deployed an API so that our design teams would be able to get the information for a type of a server, a type of a motherboard, a type of CPU, RAM, GPU, etc. For all that parameters, they would send into our model that will reply with a level of allocation, of power allocation for that typical design. And after that, we measured the actual consumption of that design that was predicted. So we could validate that it was working accordingly. And now that this model has been validated on a subset of servers, actually, because it was needed to validate that before going into a large scale, we now deployed it for the several geographical parts that we have, because if you remember, the issue is you have a typical hardware, but the use case that will run on it depends on the customers. So that means that the model is relevant for for instance, Europe or north of France, UK, because we build it for that part of the world. But the use case that will run in APAC or in North America could differ enough to prevent it to be relevant at the full scale. So that's the part that we delivered at the end, adapting the model. And now currently we are enhancing it on a day-to-day basis, because all the infrastructure changes. We have new CPUs, new RAMs, etc., etc., etc. So that's that was the first use case I wanted to present to you today. So now let's talk about the most industrial use case that you could have, predictive maintenance, because that's I think the best use case for AI today, because it's highly relevant and it has a really great return on investment. As we mentioned earlier, at OVH Cloud, we design our own water cooling system for like 20 years now. And the big advantages of the water cooling is that it cools the systems for really a small amount of energy. But the kind of drawback you can have with it is that your cooling system can be obstructed by dirt, because that's a typical way of working of water cooling systems, especially when you are using water and not chemicals. So when this kind of issues happen, it can result on the CPU having a too high temperature, or even have a water leak on the infrastructure. So you guess that having water on your computer is not something that you want to have when you provide cloud solutions. That's why we built an AI model based on an IPMI software. That's something that's gather a lot of metrics, just as before, the see, explain, and predict and prescribe. And with that data, we were able to design a predictive model that will alarm the operational teams when a CPU is presenting strange behavior, actually, that looks like it could be an issue of water cooling. And the results are tremendous at the end, because it prevented the water leaks on all the data centers that we monitored with those models, resulting in a much better operational SLA. And another predictive maintenance model that we deployed is on the network infrastructure. That's basically the same use case as the water cooling system. But the difference here is that the systems are very, very, very different. We have nearly 150,000 devices deployed all over the network of OVH Cloud, and it's growing, of course. We have nearly 150 different device models that have all their different sensors, so they are giving not exactly the same metrics. So the tricky part here was to build a data set that was representative enough to make a model on it. So we had to normalize a lot, etc., etc. But at the end, it helps us predict when hardware is failing, because you may know that between the links, actually, there is huge servers that are network servers dedicated to routing the traffic all over the world. And those servers are really, really important for our customers to keep their service running when they have services running like between UK and France, for instance. You need that link to be up. And one final, of course, AI usage that we have at OVH Cloud, I had to talk about generative AI, and especially chatbots and data privacy. Because at OVH Cloud, we are really concerned by the data privacy of our customer and our collaborators. Today, the most known services relies on private models and private and mostly American companies. But hopefully, we have also a strong open source community that's providing great models that are performant enough to be used instead of the American ones. So it guarantees us to have a sovereign service and also a privacy compatible LLM. So that's what we deployed at OVH Cloud to make for our collaborators a service, an LLM service for their day-to-day usage. We chose to work just as one of our customer, one of OVH Cloud customers, and we used the AI endpoint service that is available today to build an internal LLM. We observed quite great gains, actually, especially in operational efficiency, because it's used a lot for summarization, mail formatting, documentation formatting or reformatting, and also a lot for information search. Just as I show there, you can just ask the LLM about the data center's location, and it will answer everything, etc. So it's working really, really great. So we are now working on giving an access to other capabilities, such as code generation, because we have a lot of software developers at OVH Cloud, and also image generation, for instance, for websites, for documentation, or video generation for the, for instance, for trainings, etc., etc. And that's it for me. I think I covered the use cases I wanted to show you today. And if you have any question, I would be happy to answer it.
But thanks, Alexis, for these fascinating presentations. I think you're perfectly on time as well. So we get a few minutes left for the question, and there are quite a few questions in the chat as well. So let's start as well with our first questions, which were a lot as well towards reducing emissions. Do you calculate embodied emission in scope 3? And what do you see as the best solution to reduce emissions, energy consumption, and water usage for cooling from data center in the future, with AI use growing so fast? Yes, there are a lot of noise currently as well with the explosion of AI and the electricity needed to aliment all these data centers. So how do you see the future? And maybe the next question, which is, I'm going to ask it together because maybe it's an extension as well. How do you get the data from the industrial installation to your cloud, especially on IoT installations that might be doing more than just consuming power? So how do you bring back all this information to compute your data?
Okay, that's a complex question. Yes. Regarding the scope 3, I don't have all the information yet. But as I mentioned, we are handling almost all the supply chain for our data centers. But it's easier for us to compute all the scopes of the consumption, even if we have providers, of course, for the GPUs, motherboards, etc., etc. So I guess, correct me if I'm wrong, but I get that this scope 3 covers everything from the build up to the deployment. So we have a team dedicated to that, and we are also part of my team, which is working on building the consumption models so that we are giving back the CO2 consumption to the right server, right service, etc., etc. So that's basically how we do it today. So I do think that it's how do you call that? You know, like referentials of consumption for when they produce the services, etc., for the components. But if I may, I could get back to that if you want to, happily after this event. And then what you said, the best solution to reduce emissions. Actually, regarding the designs and how the whole IT systems are built, I personally do think that the water cooling and liquid-based cooling are the best solutions at the end regarding the energy consumption, because you optimize the transmission of heat. That's why we are working currently on a hybrid cooling system, hybrid immersion cooling system, in which we put the whole servers into a bath of a very specific liquid. Ask the R&D, not me. But they are presenting a great improvement. If I recall correctly, it's tens of or 20s of percentage of efficiency that they are gaining in cooling efficiency. But I do think there is some articles if you search for it on the net. And then for regarding the AI use, that's also a very specific topic and a quite complex one, because as the market is trusted by two main players, if they don't want to optimize their consumption, it will be really hard to make them optimize it. Hopefully, we will all work on that and make them go the right way. I'm pretty sure of that. But there is also the models that are running on those infrastructure. If you have a look on the open source community, especially on what can happen on the big hubs like Hugging Face, for instance, you can see that there is a lot of work put into making the models frugal, so they are able to work on very, very small chipsets, and even on your phone at the end or your laptop. So I deeply believe in the reduction of the model, the frugality of the models. So I hope that we will converge into something that really sustainable at the end, so that it will be able to run on the CPUs or GPUs that are very common on the market today.
And maybe another question before going as another difficult question as well from Ludovic. How does OVH anticipate the use or implementation of quantum technology in the business, in particular for handling large amount of data and to potentially lower the energy consumption? So another way to focus.
That's a bit oriented. I'm not the best one to answer that question. I think that Fanny Bouton would be she's really an expert in the domain, and she's passionate about the subject. So if you want to go deeper, ask Fanny Bouton. But if I recall correctly, the quantum today, it will more be like a topic-specific technology for encryption, security, etc., and a lot of very, very, very complex things, but directed, like focused on a very specific area, more than something that you will deploy to replace the whole IT industry as it is today. Just like the GPUs are very focused on AI, and yeah, okay, that's great. That's accelerating a kind of workload. I think that the quantum will address exactly the same type, the type of model. I think like very specific, very focused. So I'm not sure that it will be of much help. Hopefully, I'm wrong. If it helps on getting more frugal, let's take everything that is possible. But yeah, if you want to have the best answer, you should ask Fanny.
Thanks. Yeah, I understand. So maybe last two questions, so we don't get too much over time. A more technical one. So regarding LLM on the second analysis as well, so your second project, regarding LLM on RAG, do you have your own trained model or do you use standard open source LLMs? So what are your resources on this?
Yeah, we do have. We are using standard open source LLM. Today we are using a model provided by Mistral, and we do use RAG. Yeah, of course, to make it relevant when you ask questions, etc. We may use a retrained model. I don't think that we will train for the internal purpose at least. I don't think that we will retrain from zero a model, because there is companies that are doing it very, very well. And as you've seen at the beginning, OVH Cloud is a pure player. We are working with an ecosystem. We are working with great open source communities and companies, just like Mistral is doing. So we think it's much better to put effort on our main expertise and work with the best of the breed in the other fields. So yeah, we are using standard ones, and we will continue to do that, I think.
Okay. So you use open source model and you start from their open calibrations, and you recalibrate sometimes your own model as well on the back of it. And use directly calibrated model from the, okay. And maybe a last question as well to conclude as well on this, which is, yes, from Severin. What would you recommend young people wanted to come and work for OVH in the future to study on as well? Which kind of background do you like as well?
That's difficult
British background as well.
Yeah, there is a lot of jobs at OVH Cloud. You can do basically anything, because we are a very complete company. So I think that if I had to recommend something, is do what you are passionate about, what you really love to do, because OVH Cloud is really a company that has been built on passion. And every day we are all working with patient people that are expert on their fields. So that's what I would suggest, because at the end, the background does not matter that much. What matters is the effort that you put into your daily job, and what the thing that you love, the curiosity, etc.
Okay, great. So to start to work as well on their own project and maybe show passion for the subjects will be one of your
absolutely.
next things. Okay, great. But thanks a lot as well for all this insight. It was very quick, half an hour. That's the target as well. A quick lunch break. I think we will now pause the recording in our channel and share it as well with our members. And we'd like to thank you all for coming, and thanks OVH as well for your participations and all your insight into what you're doing on a daily basis.
Thank you very
Thanks
much.
a lot.